quantum physics, brain function in modern science and Buddhist philosophy. And the first session for today's, the second day is concept of subtlety, elementary particles and human cognition. For this, we have Father Dr. Matthew Chandra Kunal, Director, Ecumenical Christian Center, Whitefield, Bangalore. And we have Professor A.K. Mukhopadhyay, former professor and HOD, Laboratory Medicine, AIMS, New Delhi. Professor Partha Ghosh G, Honorary Scientist, National Academy of Science, India. And Professor Madhumita Chattopadhyay G, Department of Philosophy, Jadavpur University. May I request the chair and the speakers to take their respective seat on the dais. Before I hand over the session to our chair, may I quickly introduce Father Dr. Matthew Chandra Kunal, chair of the session. Father Dr. Matthew Chandra Kunal is at present serves as the director of the Ecumenical Christian Center, Whitefield, Bangalore. He did his postdoc from the Smithsonian Center of Astrophysics, Howard University, USA, on physics, philosophy, and religion of Galileo. He has organized conferences of national and international nature and presented papers while His Holiness the Dalai Lama was chairing the session. He has written books like Philosophy of Quantum Mechanics, From Quantum Holism to Cosmic Holism, Cosmosophy, Ascent to Truth, The Physics, Philosophy, and Religion of Galileo. May I now request the chair to proceed with the session. Thank you.
Good morning. We are entering into the second day of this wonderful conference, integrating quantum physics, brain function, and Buddhist philosophy. We have three eminent personalities: Professor Partha Ghosh, Professor Mukhopadhyay, and Professor Madhumita Chattopadhyay. And I am extremely happy that a physicist, a medical scientist or a neuroscientist, and a philosopher. So they are into the deeper realms of these three different fields and trying to find integration. So therefore, the whole details about them are already given. But I think in order to know about these people, once again, Professor A.K. Mukhopadhyay, internationally he is known as Dr. Mukho, and this name is inextricably connected with consciousness. He is an empirical scientist, a concept builder, a hypothesis generator, a silent worldview reformer, and an analyst for researchers. He coined the term and concept of supracortical consciousness in 1985 and authored books like The Dynamic Web of Supracortical Consciousness, Conquering the Brain, and The Millennium Bridge. He wrote extensively in philosophical volumes of Indian Council of Philosophical Research on the science of consciousness, on possible relationship between genes, MEMS, self-consciousness and information, relationship between dark energy and visible energy. So let us give him a big applause. And over to Professor Mukhopadhyay. He is speaking on neuroscience of human cognition to challenging frontiers. Yes, he will have Professor will have 20 minutes, so 10:35.
Good morning, everyone. Honorable Chairperson, Professor Ghosh, Professor Chattopadhyay, Mr. Damdul, and distinguished speakers, scholars, and the aspirants of consciousness. I have been given a task to talk on the neuroscience of human cognition, but I found two challenging frontiers. That's why it is Sir John Eccles, a Nobel laureate, who coined the term who brought the term quantum transmission in synapse. So he brought quantum physics in the neuroscience, and this is student of Francis Crick, Christcroft, who is a Buddhist. He turned from Catholic to Buddhism because Buddhism fit to neuroscience. So this is the connection, quantum physics, neuroscience and Buddhism. But this is brought in India by two personalities, Professor Sishi Roy and Mr. Damdul, and the first conference was held in India Habitat Center. This is the introduction part, but the Michael Gazzaniga is considered the godfather of cognitive neuroscience, and Miller, a cognitive psychology, he termed in the field of cognitive psychology, and he coined the term cognitive neuroscience in 1977. Many times we confuse the perception with cognition. Perception is a process of receiving and analyzing the external world by the cognitive apparatus of the system, distinguishing signal from the noise. But cognition refers to all the processes by which the sensory input is transformed, reduced, elaborated, stored, recovered, and used. So cognition includes all from perception to action. So consciousness, cognition, behavior is the spectrum. Everybody thinks that brain is the organ of cognition, but cognition is the operation of faculty of knowing. Cognition is the operation of faculty of knowing. Now, is it brain or psyche or both? That's the question. This is somatosensory system, then your visceral system, but cognitive neuroscience has been expanding because of the neuroimaging techniques and the computational neuroscience technique. Now, neuroimaging technique could be axial imaging or anatomical imaging and the functional imaging. So, we put the yogis under the scanner and we investigate consciousness. And there are different pictures we get of brain imaging, which indicates cognitive states of brain. It does not address the issue of cognition. This is the picture, the scanning view of the default mode when the brain is not working. Dr. Mullik was talking about the sleep. So when the brain is at rest, even that also brain keeps on working, and this is the picture or images of those. Then computational neuroscience works on the neural network theory, but it is a theoretical study with mathematical tools, and there is diverse approach, computation, electrical and communication engineering, physics, to understand the nervous system, how nervous system process information. Now, one thing I like to say, that in ganglion, there is only signal transmission, little cognition. Ganglion is the collection of nerve cells outside the nervous system, which usually in reflex, there was knee-jerk reflex. So there is no cognition there, it is just signal transmission through the nerve. Similarly, inside the brain, which is the nucleus, the red nucleus, basal ganglia nucleus, there is no cognition. There is only signal transmission. So I want to distinguish this. Physicists mostly talk about the signal transmission. neurophysiologists also work on that, but cognition is something different. Now, in the brain, there is a structure called cerebellum, on which what this John Eccles got the Nobel Prize. It is usually thought that it controls the movement, and it is ignored in cognition. But in October 2018 October, Neuron journal published an article where it is said that investigators have found that cerebellum not only controls the movement but also controls the cognition. 80% of the cerebellum are busy in quality control of what we are thinking. Here comes the astrocyte. You see, we think that brain is just synapse of the two neurons, but it is not that. Every synapse in the brain is tripartite. Brain means higher brain, not in the ganglion. There are astrocytes, and astrocytes outnumber 2 to 4 times of the neuronal number. You see, one astrocyte connects with 10,000 synapses. You see, so they produce ATPs and give it to neurons. So they are ignored in neural network theories. Now, astrocyte degeneration leads to neuronal degeneration. So we have to investigate this role of astrocyte in cognition. Now, this is another picture which is the cerebral cortex. You see the dendrites of the neurons are going up. Dr. Murlik was pointing out that action transmits the action potential, and that's why the neurons are developed. But this part is again ignored, that dendrites are going up in the cerebral cortex, and these dendrites are forming a mat at the top layer of the cortex. This gives these theories that does it receive signal from above, from the top of the head? It has to be worked out. So this is non-sensory cognition, intuitive cognition you may also call. Now, cognition has a major unconscious processing, which often we ignore. Now, there are 3 great personalities which are involved with this. One is Freud, another is Helmholtz, and another is Libet. Now, Helmholtz talks about the implicit unconsciousness, Freud talks about the dynamic unconscious, and Libet preconscious. Everything can be detailed in one lecture. But subconscious and conscious cognition, the difference is that our subconscious cognition is 90%. Conscious cognition is only 10%. Subconscious cognition is mightier. Subconscious cognition is determined by your mythos. Mythos enriches the subconscious, whereas logos enriches the conscious. Subconscious can process the things in parallel, but works on a present mode, and both these things have respective EEG correspondence. So there are various cognitive disorders in various diseases. We are not going into that. Now I am shifting from neurocognition to cellular cognition. Bacteria are small but not stupid. Published by James Shapiro, a potential Nobel laureate, did not get Nobel Prize for some reasons, but he published this paper and he showed that bacteria also have this quorum sensing ability. Even now, acellular slime mold, this cognitive process has been found. This single cell creature, it is a brainy shell. Without nervous system, it can take complex decision. This is a single cell creature. You can see it is with this signal, it is bending, then ciliary action, contraction, and finally detachment. This is Stentor Roselli. And there's so many papers have come, brainless but multi-headed. So we have to come out of the idea that cognition is only action of the brain. This is due to error in cellular perception. Now, perceiving friend as enemy, a cell is perceiving friend as enemy and enemy as friend. Now, when you perceive friend as enemy, it gives rise to autoimmunity. When you perceiving enemy as friend, this is cancer. And one is the breakdown of the brake and another is the breakdown of the accelerator of the immune system of the body. And Nobel Prize was given to these two personalities in 2018, connecting this immunological aspect of cellular perception. Why about cell only? There is a molecular cognition. Polypeptides are signal, folded proteins are informed protein, three-dimensional folded protein are knowledgeable protein, for example, enzymes, quaternary structure proteins are experience protein, for example, hemoglobin, porphyrin. So what we are saying that even in cognition, the molecules can do the cognition. So these are the different protein structure. Now, two challenges. What constitute the cognitive apparatus, the faculty of knowing, and how the faculty of cognition are related to ladder of cognition. Now, what constitute the cognitive apparatus, the faculty of knowing? Buddha says that one of the objectives of Buddha's teaching is to make individual's mind autonomous. So, mind is a cognitive organ, irrespective of God. But another great personality said, I regard consciousness as fundamental. I regard matter as derivative from consciousness. We cannot get behind consciousness. Who said? Max Planck, the father of quantum mechanics. So Planck's constant could be seen as cognitive limits of human mind, connecting Buddha and the Planck. But cognition is a faculty of life system. You usually do not see cognition in dead system. Whatever I gave the example of proteins, etc. These are within the living system. Neurons are alive and the brain wires are in fact live wires. So one of the faculty of cognition is the ability to ask question, not respond, to ask question. Now scientists have grown brain in the petri dish. And they think that this brain may be sentient. Now, can this organoid brain ask any question? It may respond to a signal like our brain responds, laboratory grown brain, but can it ask question? Asking question is a faculty of cognition. Now, what is that cognizing? I mean, what are the faculty of cognition? Local science deals with energy, matter, time, space. Non-local science, truly non-local, not without any doubt, are consciousness, mind, self, life. And these two are connected by information. Information is in the mind, information is in the silicon chips or the carbon nanoparticles. This forms the cognitive faculty, and information is the currency in the operation of cognition. Now, cognitive faculty and their cognition. Mind cognizes for signal or information. Self cognizes for phenomenon or phenomenal information. Life cognizes for symmetry, uncertainty, query, dark matter, dark energy. What consciousness cognizes for? Consciousness cognizes for wisdom, attitude in behavior. So the physical world is mainly the signal based. Now also there are people called information, but the information is formed by the mind, operation of mind. And this is connected with the self, which formats this information, and then it is connected also with the coupled. Connected means coupled with the operation of life, and life is characterized by homeostatic mechanism. So you get self, mind and information, the intelligence and memory. mind, life and information is the feelings and emotion. But there is another coupling at the top. This is consciousness. And for this coupling, you are awake, aware, experience, you can have choice and you can have will. Now we can put it in a different way. Operation of mind, operation of information, then life, whatever I have already told, emotion, then this makes your intelligence, and finally coupling with of consciousness, you get all these 5 things. Now this is connected with the informational molecules in the system biology. So the nature of the nest can be divided into this natura naturata, natura transformans and natura naturans. There is surface phenomenology, there is depth phenomenology, and there is elementary phenomenology. This is the nest 1 and 2, classical and quantum nest. Then you go to the nest 3, then the nest 4 and nest 5. It could be related to the Panchakosha model of the human body in Upanishad. Now, complex system of the cognitive faculty is juggernaut. Overarching, huge, powerful and ever dynamic. Several operators and operations are in play. Operators and operations are hierarchically organized. Systemic influence on the subsystem of, and vice versa. Pathways are labyrinthine, not linear. More than non-linear, it is labyrinthine. Now, how the faculty of cognition are related to the ladder of cognition? We usually deals with the signal, then information. These are the landmark. Then knowledge, then experience, then wisdom. Now, if you talk in the language, you can, it is a factual knowledge, it is a informative knowledge, it is a knowledge is the formative knowledge, experience is the transformative knowledge, and this is the sublime knowledge. If you talk in language of information, it is the space-time construct of information. Then this is the non-digital information, also called semantic information. Then you may have the Godelian information, the holistic information, and then information manifold, and then information crystal as wisdom. Now, so all these things need operation. You may label is operation 1, operation 2, operation 3, and operation 4. The cognitive faculty does this. This is done by mind, this is done by self, this is done by life, and this is done by consciousness. On this, one lecture can be taken. I'm just showing you the model. So this is the ladder of ascent or descent. Objective reality comes down as an experience, and then knowledge then breaks down into interrelated pieces of information, and then signal. Now, science of consciousness is being done by several groups. Those who are doing physics of life, physics of self, physics of mind, and physics of information. There are several personalities, you know, Heisenberg, Dubé, then Paul Davies, Shangchulji, Fred Wolf, Amit Goswami, then physics of mind, Henry Staff. So there are many people, Glenn, with many I am in email contact. Then this is Hoped, he is another Nobel laureate, he is doing physics of information, Jellinger, then Zude, and there is an Israel scientist. There is another person, and 2 person actually, Max Tegmark, they say is consciousness is a state of matter. So everybody is doing in their own field, but they're related to consciousness, and I think my model connected all of them. According to quantum mechanics, there is no certainty, there is only adventure. And you look at this, he's so certain he is doing meditation. So there is a long gap. Now we have produced big ideas like brain is not the organ of cognition. Organ of cognition is the driver of the brain. And so we need deep science. That complex juggernaut of cognitive apparatus has to be explored. the ladder of cognition has to be explored, and the layers between the neural signal and cognition are to be explored. This is the published paper, the layers between the neuronal signal and consciousness. So it will not be achieved in one life. There is a time frame. 21st century is the science of information and science of dark matter. 22nd century is the science of life and self. And 23rd century is the science of consciousness. So we all are working for 3 centuries ahead. Thank you.
Thank you very much, Professor Mukhopadhyaya, for this brilliant presentation. And he has drawn from his rich experience and shown to us that, you know, the world researchers, what they were doing, and also connecting with quantum physics, neurology, and then cellular connection. So let us give him a big round of applause. So now there is a paradigm shift from from neurology. Now we are moving to quantum physics, and we have a great personality who has done his great research. Professor Partha Ghosh is a honorary scientist, National Academy of Sciences, India. He obtained his DPhil science degree from Calcutta University in 1968 under the supervision of Professor Satyendra Nath Bose. He was awarded the Senior Scientist Platinum Jubilee Fellowship of the National Academy of Sciences, India, the Indira Gandhi Prize for the Popularization of Science by the Indian National Science Academy, honorary MBE from the British government, and the National Award for the Best Science and Technology Coverage in the Mass Media of the National Council for Science and Technology Communication for the period 1986-1990. He has recently edited 2 books entitled Einstein, Tagore and the Nature of Reality, and Tagore, Einstein and the Nature of Reality, Literary and Philosophical Reflections. I also have something very personally to say, that while I was doing my research on quantum mechanics and its interpretational problems, I used Professor Partha Ghosh, many of his articles in my research, and I am great. I am also meeting him for the first time, though intellectually I was connected and using many of his ideas. So I am grateful to Professor Geshela Damdul for this wonderful opportunity, calling these great minds for this doing this. So over to Professor Partha Ghosh.
Thank you very much for the kind words of introduction. As you said, there is going to be a paradigm shift. But something that Professor Mukhopadhyaya said triggered a thought in me. There's a great quotation from the famous British poet T.S. Eliot, who says, "Where is the knowledge that is lost in information? And where is the wisdom lost in knowledge?" Okay, with that, let me go to my specific topic for today, which is modeling the human mind. Now, there are whole groups of people who are using what they call quantum modeling. I will explain exactly what they do. My own view is that that's not what they're actually doing. In fact, they say so, but they use the word quantum. Actually, what they're using is what is called Hilbert spaces, which is a very technical idea. You don't need to really know a lot about it, but I will explain all this as I go along. So, quantum modeling in social science. I need to see what I have written. Now, there is this emerging area of cognitive modeling that is happening because the old classical ideas, particularly of probability theory, are not working. But it seems that the methods of quantum physics can be used to understand such phenomena. And so the logic that is used is not the logic used in quantum physics, but the logic that is used, logic that is used in classical theory, but logic that is used in quantum mechanics. Now, there is a lot of debate about what is quantum logic. I'm not going into those subtleties, but basically, in my understanding, the difference is the following. The classical logic is Boolean and Aristotelian, where you exclude the middle. It's yes, no, but nothing in between. But in quantum physics, you have to admit something between yes and no. Waves, particles, something is both a wave and a particle. This you cannot understand in terms of Aristotelian logic. That's what is meant here. So you have to go to the kind of logic which is used in quantum physics. Now, let me just briefly mention that this is something to do with multi-valued logic rather than two-valued logic. And in India, in the very old days, the Jainas came up with three-valued logic. It's called Anekantavada or Syadvada. They admit something in between. Syad, under certain circumstances, Syad Asti, it exists. Syad Nasti doesn't exist. But there is a third category of valid judgment which they use, which they say Syad Avaktavyam, cannot be expressed in words. Okay, I won't go further into it. So that is the kind of logic, and that is connected with probability theory, and that is what they are using to understand social science phenomena. Sorry, I gave some references there. Okay, so what is the main motivation? The main motivation, I'll give you an example. It's called the Guppy effect. Basically, it's a combination of concepts. Now, Guppy is a very typical example of a pet fish, but it is neither a typical example of a pet, nor is it a typical example of a fish. So this psychological behavior is unexpected in classical theory. And it implies what is called overextension and underextension of membership weights of items. And this cannot be explained by any classical model. If you do an experiment, you ask people to say whether it is a pet or it's a fish, and you give them a scale, you will find all kinds of things which you do not expect from classical logic. But that sort of thing happens in quantum physics. So that's why people are going to at least the mathematical structure of quantum theory. So I'll give you two more examples. One is a person who is neither happy nor unhappy can be in a superposition of happy, somebody who is happy, neither happy nor unhappy. But you have such states. You listen to sad music and you like it. So you are happy to hear or listen to sad music. So what is the state of your mind then? It's neither happy nor unhappy. It's somewhere in between. So you have to use multi-valued logic. An empirical answer to two incompatible questions, such as whether Lady Linda is both a feminist and a bank teller, has been found to be inconsistent with the principles of classical physics. Okay, let's see what the Linda problem is. Now, this is given to you, that Linda is 31 years of old, single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. This is given to you. Now the question that was asked is, which is more probable? Linda is a bank teller, or Linda is a bank teller and is active in the feminist movement? Now, psychologists did an experiment, and it turned out that more people went for the option B. Now, this you cannot explain in classical physics, classical logic, because if you have, if there are two events which occur simultaneously, that is in conjunction, it's more probable for any one of them to occur independently, singly, rather than for the two to occur together. Obviously, the probability will be less. But here, it's just the opposite. Linda is both a bank teller and a feminist. More people opted for that. So it shows that the human mind does not work. The logic which goes into the operation of the human mind is not classical logic. So perhaps the hope is that you can understand this in terms of the logic and mathematics of quantum physics. So quantum modeling. So to overcome the inadequacies of classical theory, the proponents of what they call quantum cognition essentially exploit the mathematical structure, which is called the Hilbert space structure of quantum theory, which naturally incorporates what is called superposition. This has been explained in great detail yesterday, and I suppose it will be again covered today. Interference in the sense of physics. If you have a double slit, it gives you, and you pass light, you see an interference pattern. So interference in that sense. Incompatibility. If two operations can be incompatible, like wearing socks and shoes. If you wear socks first and then shoes, but if you do it the other way, you get completely different, right? Or wearing vests and shirts. You first wear the vest and then the shirt. But you wear the shirt first and then the vest, you get a different result. Now, so therefore, whenever you make operations, they are not represented by numbers. They are represented by operators or matrices, which is the great insight which Heisenberg had. All right. So the claim is that this structure lies at the origin of specific effects in cognition related to the way in which the concepts and their combinations carry and influence their meaning. So for the first time, we are applying mathematical methods of quantum theory to get into cognition, meaning, and such things, which were never actually dealt with by physicists. Now, what about decoherence? This has also been talked about. The very first talk by Usha Devi was on decoherence. The fact is that quantum systems are tremendously fragile. The moment you expose them to their environment, their typical quantumness, which lies in their coherence, superposition, and all that, simply disappears, and disappears extremely fast. As Usha Devi showed yesterday, it takes 10 to the power minus 23 seconds to go. So this has become one of the big problems in quantum computation and quantum information processing, because if you want to use quantum processes, you need more time. Just 10 to the power minus 23 is hopeless. So how do you tackle this problem? So that is a technical problem which scientists and engineers are trying to solve. So now think of the mind and the brain, or whatever it is, particularly the brain. Now, it is the most complex system in the universe. It's horribly nonlinear. And obviously, because it is an open system, it interacts with the environment all the time, unless it is dead. It will decohere in absolutely like that. So how do you apply quantum theory to the brain? So my take on this is that it is not quantum theory at all which is being used. What is being used are certain mathematical methods of quantum theory. Now in mathematics, for example, take the equation for simple harmonic motion, the pendulum. The same equation applies to electrical oscillations, to sound waves, to electromagnetic waves. So therefore, the mathematics is the same, but to what physical system you apply that mathematics can differ, and their physical properties will differ. So here we are using certain mathematical methods that are used in quantum mechanics without actually saying this is quantum mechanical. So, in order not to create a confusion in people's mind, I would prefer not to use the word quantum, but simply say I'm using Hilbert space methods. And what is Hilbert space? So, Hilbert space is simply what mathematicians call a linear vector space. You can add two vectors to get a third vector. So that's and Hilbert space is a special kind of linear space in which you can define the inner product of two vectors. A dot B can be defined, and it should give you not a real number, but in general a complex number. That's all there is. So such spaces are called Hilbert spaces. Now in quantum mechanics, the states of a system are vectors in a Hilbert space. The same thing happens in classical electrodynamics, optics that we are using here. This is probably unpolarized light, but if I put a polarization filter, it will get polarized. That means there is a certain direction involved in this light called polarization, and the propagation can be described by waves, just like the waves you create in music, sound waves. Shaji talked about it yesterday. So all these waves, which are very classical, can be described in a Hilbert space. And because in Hilbert space you can add two vectors to get a third vector, that means basically that is the same as saying they can interfere with each other to produce something else. Like two waves can cancel each other out or reinforce each other. Two particles can't do that. So often when people say that quantum mechanics, they always, when they talk about classical physics, they always mean particle mechanics of Newtonian type. But there is another very important field of classical physics, which is optics, electromagnetic theory in general. It's not particles. That operates in a Hilbert space. You have interference, you can see interference of light, you have polarization, and what has been shown is that such light can also get entangled. So entanglement is not purely quantum. lots and lots of experiments have been done with classical optics where polarization and propagation can be shown to be entangled in some special forms of light. Whenever you do talk about entanglement, you have to produce that entanglement in a very specific way. So in light also, you can do some specific operations to produce a certain kind of light which has this property. They are called vortex beams, for example. I'll not go into it. The main point is that all these things do not necessarily imply any genuine quantum physics. But they are definitely telling us that the methods used, the mathematical methods used in quantum theory are more appropriate for them than classical physics. Okay, so finally, contextuality. Now, this is also something very typical of quantum mechanics, but it happens in classical light also. Usually, people say that this world, what you mean by classicality is that this world is non-contextual. What does that mean? Apparently innocuous realism about measurement, namely the conventional classical notion that physical reality must be independent of how it is measured. Measurement simply reveals what is already there. That is called a non-contextuality. But in quantum mechanics, that doesn't hold, and in classical optics also it does not hold. You can measure two different things which are compatible with each other, but in what sequence you measure or in what context you measure changes the result. Now that might appear to be quantum, but it is not. It is there in classical optics as well. But the important point is that the usual naive belief that systems exist independent of our observation or independent of the context in which they are is not correct. And this is a tremendous realization. So finally, I'll just talk very briefly about selectiveness of influences in psychology. For example, the media gives out some news all the time. But every one of us selectively gets something out of it. That depends on our state of knowledge, our background, our current state of the mind, and so many other factors. So we selectively take out information from what is presented. This also is very difficult to explain in terms of usual classical theory. And Zafarov has particularly Zafarov is shown that this kind of contextuality and probability, that is, what is the probability that Ramdulji will take out something from my lecture, and what will he take out from my lecture? One can make probabilistic calculations. Now that probability calculus which you use cannot be, or if you use the classical one, you will fail. So you have to use something else which is called quantum. So, my final message, as it were, is that Hilbert space is not unique to quantum mechanics. When we learned quantum mechanics, as you probably also did, we were told that the big thing about quantum mechanics and the big difference with classical physics is that quantum mechanics uses Hilbert spaces. So whole generation of physicists believe that. So whenever you say Hilbert space, they say, oh, that's quantum. That is not correct. Now it is gradually getting clearer and clearer that Hilbert spaces are much more general. You have to add specific axioms to make that a Hilbert space into a quantum Hilbert space. Thank you very much.
Well, dear friends, as I was listening to Professor Ghosh, I was finding a confusion. It was uncertain whether he was a physicist or a mathematician. He was, I think, both as a particle and wave. He was speaking from a mathematics point of view as well as a physicist point of view. So thank you very much for this brilliant presentation. And let us give him a round of big applause. And now we are going into the deeper sections of Buddhist epistemology and the philosophical trends by Professor Madhumita Chattopadhyaya, and she is also an eminent scholar, teaches philosophy at Yadavpur University. She is also the coordinator for the Center for Buddhist Studies, Yadavpur University. She has been well trained in both Western and Indian philosophical traditions. After her PhD, she shifted her research area from Western logic to Buddhism. She has authored 4 books, including What to Do with the Liar, Walking Along the Path of Buddhist Epistemology, Ratnakirti on Apoha, Philosophical Thoughts of Nagarjuna. She has also been awarded several prestigious international fellowships like Fulbright Visiting Fellow, Japan Society for the Promotion of Science, Long-Term Invitational Fellowship, Bukkyo Dendo Koyokai Fellowship, and Charles Wallace, among others. Over to Professor Madhumita Chattopadhyaya. Let us give her a big applause. Yes.
Stand here. Good morning, everybody. After hearing such nice papers by Professor Mukhopadhyaya and Professor Ghosh, I am really very much surprised whether my paper at all will go with them or not. I have tried to express my view on human cognition as has been upheld by the Buddhists. Now, of the different concepts highlighted by Lord Buddha in his different discourses, the fundamental one is that of consciousness or vijnana. In the very first twin verses of the text Dhammapada, it has been said, Mono pubbam gama dhamma, mono setcho monomoya. That is, mind precedes all dhammos, and the mind is the best, and everything is the product of mind. Though the term mind or monos is used here, it is actually used not in the sense of inner sense organ which feels pleasure or pain, but is used in the sense of consciousness or chitta. In fact, in the whole Abhidharma literature, monos, chitta and vijnana are used as synonyms. This consciousness or vijnana is a Pali term whose Sanskrit is vijnana, plays the most important role in Buddhism. It is this consciousness which can account for the continuity of individuals through different births without admitting any permanent or eternal self. It also explains a man's progress towards the stage of an arhat, transcending the mundane life to the supramundane one. In these two aspects, consciousness takes different forms. Consciousness without any object and consciousness with an object or consciousness with regard to an object. The first variety is exhibited The first variety is exhibited in the Potishondhi Chitta, Bhavango Chitta and Chuti Chitta, which account for the life continuum of the individual. This life continuum is possible because of the impressions retained in the mind from the past experiences. These experiences are nothing but our past cognitions which arise out of objects. So in a sense, those two aspects of consciousness are very much related and at the same time separate. Cognition of the objects give rise to the emotions of greed, love, hatred, desha, and attachment moho, which are responsible for our bondage in the world. As such, in the Dhammapada, it has been said that our mind or consciousness is responsible for our bondage to the worlds of kama, that is the sensible objects, rupa, world of forms, and arupa loka, that is world of formless objects, which is these three worlds are conceived of as mara in Buddhist literature. So, of the two aspects of consciousness, the second one, that is consciousness with regard to an object, is the most important one, and it has been referred to as human cognition. Except the ultimate stage, which is regarded as a stage of nirvana, where consciousness shines in its own light without any object, in all other stages, consciousness is intentional, that is, consciousness is always consciousness of something. But what this something is has been the subject of inquiry. The Buddhists believe that objects of consciousness can never be anything gross. It is always subtle, elementary particles. It is our conceptual cognitions, vikalpa buddhi, which impose grossness to a cluster of elementary particles and makes our pragmatic behavior possible. In my present paper, my objective is to concentrate on the question if in reality there are only such elementary possibles, how can there be human cognitions? And without human cognitions, how can we explain the life continuum? So the question that I will focus on is, how is cognition of external objects possible? This question I will try to discuss following two Buddhist schools, namely the Vijnanavada, and the Shautrantika school, based specially on the works of Bushubandhu Dingnago and Dharmakirti. We all know that Bushubandhu in the early part of his life, in the stage of Abhidharmakosha, admitted the reality of atoms or paramanu and the kalapa or the collection of such atoms as the object of our cognition. But in the second phase of his philosophical career, under the influence of his brother or stepbrother Asango, he changed his position to Vijnanavada. Now, in this stage, in his text Vinshotika, he actually says that natad ekam nacha anekam vishaya paramanusha nachate sanghata yasmat paramanu na siddhati. That is, he said that existence of atoms cannot be admitted. Existence of atoms as either elementary particles and consequently as the collection of atoms like color, sound, etc. cannot be admitted. In the same line of thought, Dingnago in his Alambana Poriksha, in the very first verse, announces that though the atoms as the object of cognition appear to be the cause of sense cognition or Indriya Vigyapti, still such atoms do not have any existence like the sense organs. Boshubandhu and Dingnago both are trying to establish that there is no one-to-one correspondence between images that we have and the external objects. And given that no experience can occur without consciousness, consciousness is the basic presupposition of any experience. Forms of subjectivity as well as objectivity are manifestations of the same consciousness. This is the most important part in the views of Boshubandhu and Dingnago. They say that forms of subjectivity, that is cognition, as well as objectivity, that is the part cognition of something, this something, they are the manifestations of the same consciousness. But neither is there any personal ego or any external object. Now, a problem is that if we do not admit the existence of any external object and recognize the reality of consciousness alone, how is it possible to distinguish between the consciousness or cognition of a jar and the consciousness or cognition of a table? For both are nothing but consciousness, and as consciousness they are the same, and there is not anything else by which they can be distinguished. Now, Dingnago's reply here is that he tries to show that the nature of the object of knowledge, which he very clearly announces as Jad antargyo rupam tu bohirpad abobhasate so artho bigyano rupotva tat pratyaya toyapicha. It is the object, that is the ortho, which exists internally in knowledge itself as a knowable aspect, and that appears to us as if it exists outside. We have in our mind representations, ideas or images of a world that appear to us as external and that we regard as real. Such representations are regarded by Dingnago as antargyo. Thus, the internal consciousness is endowed with two parts. It is an image, and at the same time, it is the cause, which they regard as alambana pratyaya of the consciousness itself. The sense organ, which is regarded as the cause, adhipati pratyaya of sensory cognition, is nothing but the force itself, shakti, in consciousness, which gives rise to consciousness itself. Now, to account for our pragmatic day-to-day behavior, which is not possible without any external object, the Vijnanavadins make a distinction between three types of essences of objects, which they regard parikalpita satya, that is, parikalpita satya means imaginary nature, paratantra satya, dependent nature, and parinishpanna satya, that is ultimate nature. They hold that such pragmatic activities are possible only because we superimpose an essence, svabhava, to an object. This superimposition explains how our daily activities can be possible. The Shautrantika school, on the other hand, does not believe in this triple essence theory of objects. They try to explain reality in terms of causal efficiency, which they term as orthokriya karitva. This nature of causal efficiency, they say, can be found only in the case of unique particulars, which they term as salakshana. So in their language, salakshanas alone are real. Now, a problem arises. Even this way of defining reality in terms of causal efficiency could solve the original problem. That is how we can speak of our knowledge of external objects. The original problem apparently seems to be resolved. But because we are here defining objects in terms of their pragmatic utility, that is their causal efficiency, so the problem apparently seems to be solved, because the causal efficiency of the jar and the causal efficiency of the table being different, we can account for the difference of the cognition of the table and the cognition of the jar. But the problem, a new problem arises. Unless we identify a particular as a jar or as a table, we cannot make use of those elementary particles in our practical life. So, though the original problem is resolved, a new problem arises. In the text Nayabindu, where he talks about these shalakshanas as paramartha sat or as sat, Dharmakirti makes a distinction between two types of objects. One as grahya object, that is object cognized, and adhyavasaya, that is object imposed. The shalakshanas, or the unique particular, is regarded as real in the case of perception, for that alone is non-erroneous, free from all sorts of error, all sorts of dispositions. So that is the grahya, that is the object of our knowledge. But the objects which serve our purpose, when they are considered as jar or as milk, that is, when a character is there, we think that the object is milk or the object is jar, then this character of being a milk or being a jar, this character, according to Dharmakirti, is not actually there in the object. It is, this character is imposed by the cognizer on the object. So this imposed object, which in his terminology is adhyavasaya, actually serves our pragmatic utility, but this disposition is completely dependent on the subject, and so there is every chance that the imposition that I am attributing to the object is not actually what the object is. So there is every possibility of error. So he says that this adhyavasaya that cannot be regarded as real in the ultimate sense. This distinction between grahya and adhyavasaya thus shows that the shalakshana, which is actually real, is real only as grahya. And what is grahya is nothing but the object of cognition. So the reality that Dharmakirti as a Shautrantika seems to be speaking of in the case of shalakshana is not the ontological reality which the realists there is a grammatical mistake, want to assign to the particulars. Now here a problem is, Dharmakirti has regarded the salakshana as paramartha sat or ultimately real. But now we find that he is regarded the salakshana to be real only as a grahya, that is, only its reality is in the epistemological level. So there seems to be an inconsistency in his two approaches. In the approach found in the Nayabindu text Nayabindu, there is a spelling mistake also here, and that of Pramano Bhartika. But the problem, but the answer that we can give to resolve this problem can be found in his commentator Manoratha Nondi's commentary. There he points out that when Dharmakirti is actually saying that causally efficient entity alone is ultimately real, he is understanding orthokriya samartha, that is causal efficiency, in the sense as revealing the nature of the structure of cognition. In Sanskrit, orthokriyayam gyanadikayam sarupa upodhaneno samartham jat tad atra bostu vichare paramartha sat. That which has capacity or efficiency in such a sense that alone can be regarded as ultimately real from the point of view of evaluating the objects. This shalakshana alone is sa-samvedana or self-consciousness, which alone is the only reality. That is why it was possible for him to admit the reality of cognition as consciousness alone, like the Vijnanavadin in his magnum opus Pramana Bhartika, without involving in any sort of inconsistency which is found in the inconsistency with what he said in the text Nyayavendu. Thank you.
Quoting the great masters like Dharmakirti, Vasubandhu, Asanga, Diknaga and the others, Professor Madhumida Chattopadhyaya has led us into the deeper dimensions of cognition in Buddhist epistemology. So let us give her a big round of applause. So friends, we had a very deep yes, we have deep questions on physics, metaphysics and neuroscience, on cognition and consciousness. So really deeper research has been done and presented by these great scholars. Now we have time for 2 questions. Oh, so many are there. Geshe-la, what shall I do? 1, 2, 3. Maybe I think yes, Geshe-la has given us the time. So we will have all the questions together and let it be brief, and then the 3 of them will be answering. Is that fine? Yes, sir. I think that is it. So yes, first one, lady, please.
Hello. So my question is to Professor Mukhopadhyay. So you explained the operation of mind, but so I know you didn't touch that topic, but I really had that doubt that how would you explain when a individual go through schizophrenia? So how does it affect the operation of mind?
That is basically psychology. That is psychology and the neuroscience. This is the topic of the discussion. I am not going to be detailed. We can discuss it.
Yeah, maybe later. So please, the second one, Monk. Yeah, yes, here. 3rd one there, 4th one there.
My question is for Dr. Partha Ghosh. From my some understanding about the physics, like if we see diffraction like basic physics phenomena, so wave particle when the separate occurs, so we say it's a wave. It can't be defined by particle, right? So when the diffraction phenomena, when the interference happens, so we can explain it through the wave-like nature, right? So quantum physics means when the particle acts as a wave. When the particle acts as a wave to some extent, like, so it's not always we have to use external physics to say whether quantum state can stay for some nanoseconds or whatever it is. So if something that could be described as a wave, I will say we are in the quantum realm. And if mathematics is there to model that wave-like nature of any phenomena, I will call that quantum mechanics. Can you please answer that? Because you said these guys are using some mathematical tools from quantum mechanics, so it's not real quantum mechanics. But I say whether it's electronic phenomena like quantum tunneling or we have quantum wells, there we use quantum mechanics because the nature of that phenomena is like a wave-like. And then the quantum mechanics gives us tools. So if we see that concept, then it's quantum mechanics. Please help me.
Well, in physics, of course, you have to use quantum mechanics because a lot of phenomena cannot be otherwise explained. Now, I thought you asked what about decoherence, right? No. Okay.
No, I think
we'll talk about later.
Debate, then definitely we will take. Yes.
Okay. Can we take it during tea time?
Yes.
Yeah, with due regards to the chair, I think I may not get a chance, but I must speak because it has been said repeatedly what Biren Malik has said. I think about EEG, what I said is a general principle. It is a synaptic potential. It's not action potential. So quite often, what I hear since yesterday, so many of us, we talk about somebody saying something without losing completely the context and representing in a different way. It's not the way that the conference should go. So yesterday I talked about EEG, and that is synaptic potential, not the action potential, which was misrepresented by the speaker. And that is, there's no wonder that was said. Biren Malik has said this, so it was not. If I had said that, that was a misway to represent our understanding. Therefore, I said I must speak that and clarify in the August gathering. Thank you.
So the next person is here. Okay, yes.
Thank you. Thank you all for your amazing talks. I'm interested in knowing from Professor Mukhopadhyay, excuse my my pronunciation, I'm here. One of your slides, you mentioned that the Buddhist teaching is to make us autonomous from a god or goddess, and I found that quite intriguing because it's not my understanding at all of what the Buddha is teaching. The Buddha is teaching that we're anything but autonomous because we are radically interrelated. So I would like to invite you please to explain what you meant by that in your slide.
Which is autonomous?
You mentioned that the Buddhist teaching is intended to make us autonomous from a god, I believe, of one of your slides.
These I quoted from some book, I do not know. To make the mind autonomous, independent of any god or goddess.
But the mind cannot be independent from any phenomena. That's my point. But I just wanted to understand, because I thought it was a bit of a misrepresentation of the Buddhist.
I have not gone into it.
Okay, thank you.
From some books.
It's a very important point, as everything is interdependent. Pratitya Samutpada is such a fundamental point of the Buddhist teaching. I just wanted to say thank you.
Please.
Good morning. This is for Dr. Mukhopadhyay. So you mentioned in one of the slides on the brainless but multi-headed. So the three concepts: neural cognition, cellular cognition, and molecular cognition. So can you just add a light with respect to molecular cognition? You mentioned about viruses, and there's some new particles called prions. infectious particles which affects the brain cells and causes a disease. But it doesn't have a cell, nothing. But it works brilliantly in causing infection of the brain and causing disorders. Can you please add light on that?
Yes, there is a lot of disease called Priam's disease. Priam's disease, the Creutzfeldt-Jacobs disease, this cannibalism, all these things comes from this prion. And prion is not even a DNA. Prion is just a protein. So it is just protein which is an infectious proteinaceous agent. It is infecting the human brain. So you're right. So cognition is not confined. The cognitive faculty is not just, it is of brain, but it is even, you can get it in molecules, even it got in cell. That is what I told. And you are right.
Yeah, so the last one. So many are there, what? Okay, we'll get to the monk.
Okay, thank you. So actually this is also for Professor Ghosh, which is probably a similar question to the gentleman, but I'll try to say it shorter. So how do you actually distinguish between describing a phenomena with quantum mathematics and it being a quantum phenomena? Just
Well, first of all, for dealing with atomic and subatomic phenomena, we know that we have to use quantum mechanics. That's the best description. There's no two ways about that. The question is, when we talk about perceptions, combination of concepts, decisions, and so on, classical methods fail. So people are saying, okay, let's use quantum methods. What I was trying to say is they do not mean actual quantum phenomena. They are simply using the methods of quantum mechanics. And therefore, my view is that they should simply say, we are using Hilbert space methods. So the phenomena, I mean, mental phenomena, consciousness, things like that, belong to a different realm from atomic and subatomic physics.
Thank you. I think there are lots of questions, still more, but unfortunately, because of the time frame, we have to cut short. But the presenters, the speakers, they will be here. We can go for interacting with them. And I must say that this was such a wonderful session, and lots of questions were generated, and many of the questions, we could not answer, and it will take lots of time, but let us thank the three speakers who were great scholars from quantum physics, neuroscience, and philosophy, and with a big round of applause, let us thank them. So now I think that we will break for tea, and when we need to come back, she will be. Thank you very much.
Thank you, Father Matthew G. Now may I request Professor Partha Ghosh Ji, keynote speaker of the conference, to felicitate the chair and the speakers.
Yes. You have to meet.
Father Dr. Matthew Chandra Kunal Ji. Dr. A.K. Mukhopadhyay Ji. And Professor Madhumita Chattopadhyay Ji.
Thank you.
Thank you. We'll break for tea now and we'll come back at 11:45. The next session is on substance, form and interaction in Buddhist philosophy and quantum physics. Thank you.